to anyone who are streaming and doing sessions. You have to go to YouTube and click the button start streaming before you do the introductions. That is very important, and I cannot stress it enough. Hello, my name is Alex Life, and I am very happy to welcome you to Virtual Jug. It's a very special online-only user group, Java user group, which you can join online from anywhere in the world. We do world-class technical sessions, and I'm absolutely happy and delighted to be currently here and meet you. Today's session is special for a number of reasons. It's my pleasure to introduce the new member of the Virtual Jug team who will help us with running the sessions and organizing the best online Java use group. And of course, this is a very interesting session about Kubernetes by Ray Tsang. So let me share my screen really quickly and go through necessary details because I just need to do that because I was preparing those slides for like literally 10 minutes. So welcome, Virtual Jug. You're watching this on YouTube, so share the link to YouTube with all your colleagues, all your Java developers that you know, and everyone else actually, because the world could be a better place if we all learn something about Kubernetes today. My name is Alex Shalaf. You can find me online on Twitter. During my day job, I work for GraalVM team at Work Labs. It's a high-performance runtime that can run programs in many, many languages. You should check it out if you haven't seen that yet. And today we have Laurie with us, Laurie LaRusso, and you can find her at Twitter. She goes by @Laurie LaRusso, and she's currently working at JFrog. Hey, Laurie.
Hey, Oleg.
Let me stop sharing the screen. Can you introduce yourself for a second, like just really quickly in one sentence?
My name is Laurie. I work with a lot of techies. I used to work for Oracle, used to help with the Java champions, the groundbreakers, the aces, and now I'm at JFrog and a part of VJug and super happy to be here.
Right. We're very happy to welcome you to the team. I think it will be a great addition and you will help us to elevate Virtual Jug to new levels. So I'm also kind of happy to say that Snick is very generously helping us with the Zoom accounts and everything, some infrastructure. So technically Snick is the sponsor of Virtual Jug. They do developer tooling with the concentration focus on security and vulnerabilities. If you're watching this live, this is, and I cannot stress how important this is, you should join the Virtual Jug Slack. The Slack workspace, you can find the links in the description on the YouTube, and just go to the channel live session. This is a place where you can ask questions and we will forward your questions to Ray, to our speaker. You're also welcome to share the group and session. And if you have any feedback, just hit us on Twitter by @VirtualJug or directly to me @Schleif. And I'll be happy to forward your request to the people responsible for that. Today's sessions is learnings from the Implementing Microservices Architecture with Kubernetes. And you can find Ray on Twitter. He goes by @Saturnism. Our next session will be also in a few days, but today that's all for me. So I will give control to Ray, and I would like to welcome Ray. And I would like to unmute Ray, but he's still muted.
Oh, there we go.
And hey, Ray, how are you doing?
I'm doing all right. Yeah, it's interesting times.
Yeah, it is very hard. It's very hard. We are living through very interesting challenges currently, and I know very many public events and social gatherings have been canceled. So it's very nice that Virtual Jug can be of a little bit of a service and provide some education and entertainment to the world community. So without further ado, Ray is here. Ray is a developer advocate for Google Cloud Platform. He's a Java champion. He's an expert in many, many things. The legend says that if you say Kubernetes 3 times in a row, Ray will appear and answer your questions. So he's definitely a person to learn from. So that's what we'll do today. And Ray, the stage is yours. Take it from here, please.
Okay, let me go ahead and share. And here we go. All right, cool. Thanks everyone for joining this virtual session. It is indeed an interesting time. I'm actually based in New York, and things are evolving very, very quickly. So yeah. I'm a developer advocate for Google Cloud Platform. Oleg actually said everything that I wanted to say. So thanks, Oleg. However, you can actually join me on Twitter at Satanism. So if you have any questions, you can find me there. And you can also find many of my previous sessions, materials, links to many of the tools and ideas I'm going to share today. You can find it on my website, which is satanism.me. Now, aside from technology, I've been in the industry for about 15 years now, primarily with Java. But aside from technology, I love to travel. I love to take photos. And this is one of a special photo for me. I was actually traveling in China at the time. I was backpacking in China a very, very long time ago. And as a backpacker, I needed a place to stay in this one area, and they had no cheap places. So I had to, the only option were really expensive hotels. And so I asked around, and somebody said, well, if you actually take a bus a couple hours out, you can find the desert. And then once you get off, you can walk into the desert for about 4 hours for 4 hours in the southwest direction. And if you find the oasis, you can stay there for free. And my first question then is, well, it's free, so what's the bus? Right? I don't know if anyone here hiked in the desert before, but it is not like walking on the beach. It's definitely not the same. The sand is really, really soft, and every step that you take, your foot is gonna sink a little bit, and you have to pull yourself out. And when somebody tells you to walk in one direction in the desert for 4 hours, you go straight, no matter what's in front of you. So you can see in this photo, there are a lot of these sand dunes. And so you have to go up and down these sand dunes and pull your foot off every single step. It's hot, it's dry, I got water, it's heavy. And I was on vacation, and I thought, wow, this feels like going back to the office and writing a J2EE application back in the day. And but the end though was really, really beautiful. The end was absolutely gorgeous. This is one of the photos I took. I forgot whether it's sunset or sunrise, but this is the oasis, and the end is beautiful. And this is where I think that a lot of people wants to get to, which is production. The road to production is not always easy. The road to production may have many challenges that we have to solve. We have to make a lot of decisions on. But once we get into production and seeing that users are using it, and we're generating value for the business, that's a very, very beautiful place to be. And that's where we want to go. So hopefully today, I'm going to share some of the experiences, hands-on experiences that I had in the past year involving a project, and some of the lessons learned to hopefully help you to get to that state much, much easier. So the project I was on, I was there for about 6 months. And the project was for one of the Alphabet companies. Google is one of the Alphabet subsidiaries, and there are many different Alphabet companies. And I was helping one of these companies with their own internal project that is actually going to be potentially used by the public, right? And we are using open technology like Spring Boot, Kubernetes, and the whole thing, right? So we basically have to bootstrap everything from nothing in a way. And the architecture looks something like this. This is the very high level architecture of what we actually produced from the infrastructure perspective, right? We're running everything on Google Cloud for some of the environments, but we might be running production, in different areas. So in this case, we have like a private Kubernetes cluster, and we're running our app, the front end and the back end and other services in a project namespace. And then we have a database, we got image registry, and we have load balancing, of course, for ingress traffic. But more than that, we also lay down a service mesh in the middle, which helps us to load balance our internal requests and also access the ingress proxy, the ingress gateway that will receive incoming requests and routing the traffic to the backends as well. And one of the nice things about the service mesh, which is we're using EachDo, is that all of the telemetries, all of the metrics about the request latency and success rates and failure rates, all of those are automatically captured, and then we can surface the information to Prometheus, Grafana, and stuff like that. In addition, we also control in a production environment. We also control all the egresses as well. right? So for example, if somebody were to get into the system, they are not going to be able to get out except for the whitelisted egress points. So for example, we do use some third-party services for different things, and these applications would have to go to the egress, which is tightly controlled. We whitelist all the egress endpoints so that only those endpoints can be allowed through, and we're also using EachDo for that. So that's a very high-level look of this app, front end and maybe over a dozen microservices today. Okay. And one of the first things that when I joined the project, what I saw was that there were developers who are trying to learn all of these new technologies, right? They can go to the console and we can very easily click a few buttons and we can have an entire Kubernetes cluster up and running in a few minutes, right? And that's, for example, on GKE, you just go click 2 buttons and then you get a whole GKE cluster. That's pretty much, production ready, except that we need to harden it even more, right? But as what we found is that, even though this is a really, really easy way to click through the consoles and creating these environments, creating, say, the registry, creating the SQL database, creating the load balancer and stuff like that, it's really, really hard to produce, right? So I think that is probably the first thing that we had to do in this entire architecture, which is to turn the idea of just being able to generate your environment from ClickOps and turning that into GitOps, right? So what we have done then is to make sure that we have the entire infrastructure reproducible via some tool. In this case, for the infrastructure level, we're using Terraform. Okay. So with Terraform, what we did is we wrote some Terraform templates and scripts so that we can just run the Terraform apply, and it will recreate the entire infrastructure for us from the VPC networking to the load balancing to IP addresses and to the entire cluster. But we went even further. We also use Terraform in conjunction with Kubernetes YAMLs that deploys EachDo. We use both of them together so that once I Terraform my environment, not only do I get the entire cluster, but also get all of the facilities that I need, like EachDo, the service mesh. And the only thing that's open up then is the namespace, which I can then deploy my application to. Okay, and Terraform is a very you can go very deep topic into Terraform, right? So we're not gonna go into the details here, but just remember that you always wanna think about how do you document and check in your environment as code or configuration so that you can later reapply them very easily and even automating it with GitOps with the CI/CD pipeline. So in this case, for our Terraform, we split it up into different environments like dev, staging, prod, and a few other environments I'm not listing here. And then they share some common modules so that we don't have to rewrite, like, how do I want to provision a SQL database over and over again? We can just use the module, and then we can tune some of the parameters, like the number of nodes or the amount of memory that I want to assign to different environments. Okay. And once you apply the Terraform stuff, Terraform actually keeps the state somewhere. So initially, the team kept the state locally on their own machine. So if I run Terraform, if you run Terraform, we both will have different state. And if I run Terraform again after you apply any changes, I'm not going to see those states in my own Terraform local states, right? So it's very important in this area to think about how do you document the state in a shared environment. So Terraform actually do have a different backends that you can use. So in my case, we're using just Google Cloud Storage as the backend, so that everyone on the team who has access is able to see the current state, and they can do the Terraform plain apply to get to the latest environments. Okay, so that's what we have done. Just make sure that you first of all think about GitHub everything, checking all the configurations. Now, before we even that's just infrastructure, but before we even start to think about the targeting environment, I think what's really important is that for any application development, it all starts with local development, right? It all starts with your app. And one thing that I learned is that through this whole process is that local development environment is not production, right? It just isn't. As much as people say, hey, you can build a container image and create a YAML file that will run locally, and you just deploy that into production, and everything will just work as is. That is definitely not the case, because production environment is hardened. It has a lot more complexity in the production environment. If you bring those complexity down to the local development, and you say, well, let me just make my local development exactly the same as production, you're looking at a very difficult problem, because the production environment is constantly changing. It's constantly being hardened. And there are so many things you have laid into it that you might just be stuck in a long time to create a production environment where you can be doing development, okay? And also, once you have all of these components that only exist in production into your local, you're going to be using a lot more resources than you need, and it's going to slow you down. So what we did is that, of course, the local development, we have a local development track, and production environments and staging environments, the operating environments are being produced separately in parallel, right, as we go and harden these infrastructure. For local, I think what you need to be focused on is about the development productivity. It's all about productivity. It's all about how fast, how quickly can you produce value with the code that you write, right, with the right tools, and now you can iterate fast. Okay, you don't want to be bogged down by all of these environment stuff. You need to focus on the design and making design decisions that will be long lasting. And we're going to see this over and over again on how we make these choices later. Okay. And last advice here is just actually don't start with Kubernetes. In fact, when you're designing your microservices, you should design your microservices regardless of the environment that you're running in, because the environment is always changing. A couple of years ago, it could be a platform as a service. A number of years ago, it could be a machine. And today is Kubernetes, and tomorrow it could be something else. But what's important is that you design your application in microservice properly. Okay. And one of the best tip I can give is to just get started with 12-factor apps. I'm constantly surprised by how many people who haven't heard about it. And also for people who have heard about it, how most people don't implement more than 2 factors, right? So it's very important to actually understand the 12 factors and how they actually apply to Kubernetes. And I do know that VJOG actually had a really good session in the past about 12-factor apps in Kubernetes. I'm assuming that's all recorded, so you should definitely check it out. But everyone should at least have 1 factor here, because one of the first factor is checking your code. Everyone should have this. And the reason why people don't know is because we don't fully understand what all the factors are. Another thing that's really important is make sure your configuration can be stored externally. And as Java developers, what I used to do was to hard code my properties files, and I package it as part of my jar. And there was no way for me to override any of those configurations. And so if I need to make a config change, I would have to go and recompile, redeploy, and that will slow you down. So that's one of the factors here. Another one is to make sure that your application is stateless, right? Or that you can listen on different port. And also you handle graceful shutdown. And there are many items here that we will actually see later, as they are all very important in a Kubernetes context. The other thing about local development is that you want to make sure that you can test and run your app, hopefully without any complexity, right? What I mean by that is that you should be able to, with your level of your team, right, with the current expertise, you should be able to just clone and run your app, and clone and run the tests, right? So local testing and local runs are very important here. And you want to make sure that all the tests can be done locally and they're reproducible. And if there are any flaky tests because of external dependencies, you gotta fix them and see how you can fix these external dependencies. And one of the easiest way that I found is, and this is also getting very popular, is a project called test containers. So with test containers, you can actually launch external services as long as they're packaged as containers. You can launch these services as part of your unit test cycle, okay, or integration test cycle. Okay, so that at the beginning of the test, you can launch, say, PostgreSQL, and then you can run through the test with a real PostgreSQL, and then at the end of that test, it will shut it down. So let me go and see if I have a simple code here. So in this app, this is a Maven app with a very simple example of a Spring Boot application. And it's using Spring Data JPA. We got the repository here, and it's using PostgreSQL behind the scenes. Okay. Now, what happened then is for the unit testing, we can actually use the test container stuff so that, first of all, you can add the dependencies. So definitely look this up. You can add the dependencies. So here's the test container dependencies. They have additional support for some specific services like Postgres and Redis and a few others. So you can avoid some boilerplate code. And then this is the one that hooks into the annotation that hooks into the lifecycle of JUnit 5, I believe. Okay, and then in my test, all I need to do is to specify that it's a test container test, right? I'm using test container, and my container needs to hook into the lifecycle with the container annotation. And for this particular code, I am using very specifically the PostgreSQL container, so that they give you these nice methods to configure the database name, the username, and password. But then the important part here is to just set the image name to the version of Postgres that you want to use. And then you can configure the data source. And all of these metadata is already captured here in this container object. So when you're configuring it, you can set it with system properties. You can override it with the application context initializer. Or in my case, in the Spring Boot application, I'm literally just creating a data source to be reused. Now, if I want to run this test, let me run my test right here. Run. Uh-oh. Where's the, there it is. What this will do is to, in this cycle, I'm going to zoom in a little bit if this works. In this cycle, it's going to start my Postgres database, okay? And then starting my app for the test, and then run through the test. And at the end of the test, it destroys the database too. And so you can set up the database in a clean state, and then so that your test is very reproducible. And you can use the same trick even if you have external microservices that you want to use, or some kind of stub that you can that's not in Java and you have to bring it in. Then you can containerize it, and then you can also create like a generic container like that. So like my container is equal to new generic container, and then you can just give it whatever container image that you want to download, and just annotate it. And now this container will be started, listen on a port that you can actually access. So again, just some tips to make sure that your application can be tested and run locally. Now, what I also learned just from Sergey yesterday, actually, that he actually have another blog on how to use test containers even during local run. So what I showed just now is how to use test containers in testing, but you can actually bootstrap your application with a test application that will also start these containers for you, so that your application can run locally even without a Docker file or a Docker Compose file or anything like that. And that is a really, really cool part. And then you can debug your app locally as if it's just it is just a local application. Okay. Now, the second challenge is that we met very, very early on in this journey. By the way, this is a journey and the lessons learned about this project, right? So the second journey, the second part of this is code repository. When you are developing microservices application, no matter where you deploy it to, one of the first question is Mono Repo or multi-repo. That is a big decision to make, and we also have to make that decision as well. And the way to really think about it is that usually the way I think about it was is it a distributed monolith, right? Because in Mono Repo, every service that you create has to be following the same lifecycle potentially, that they have to potentially build and test at the same time, right? They're tightly coupled in a way. If you're not careful, that's the case. Or are you building a distributed services, right? That's how sometimes some people think about choosing between Mono Repo and multi-repo. But in reality, you can also have distributed services with Mono Repo too. In fact, at Google, we only have Mono Repo, right? And we do have many, many distributed services. So this thinking for me wasn't correct, right? And what was really, really challenging was to make that decision without being blinded by tying the application architecture with the repository that you choose. So it really depends. And we actually have to think a lot about the pros and cons of these repositories. And this is one of the things that we always do, is that we document these decision points. We have a doc where we document the pros and cons. We have a lot of discussions around these. and we make a decision at the end of the day, and then we go with it. Okay, so every decision that you ever have to make, it's always really good to document it, have a discussion with your peers and others, and also weigh in all the different perspectives and pros and cons. So there are many pros and cons for either approach, right? For Mono Repo, it's really, really easy to get started. You just need a single CSD pipeline in most cases, in which case you can just set it up quickly too. It was really a way to get velocity because it's easy, right? For multi-repo, even though it's best matched with the microservices environment, but it does take a lot more infrastructure to set up. So for example, CI/CD pipeline. Instead of just one pipeline, now we need multiple pipeline. And if one of these pipeline changes, we ever decided that we need to change the way that we deploy the app, then we have to go back and modify every single one of these pipelines, right? And that can be very time consuming, let alone setting it up. Another thing is that if you do have multiple repos, you do need to find a way to share your artifacts, right? So if you have a common library in a mono repo, it's really, really easy to just consume and use this common library. In a multi-repo, of course, you would have to have proper versioning for your libraries. You need to be able to publish it to a central location like a Maven repository. And now somebody has to set up the Maven repository, right? And somebody have to maintain it. And if it's mission critical, now you have to set up a highly available Maven repository or something like that, right? So there are a lot of these things that you have to consider. And for multi-repo, it was going to be slower to get started unless if you have existing infrastructure you can leverage. So you just really have to weigh the pros and cons. And ultimately, you need to see which one fits your use case the best. So we actually chose to use the mono repo because the team is already familiar with it. And also, we only have like 4 or 5 people, right? So we didn't have a big team to maintain all of the infrastructure at all. And so mono repo was a natural choice. And we also didn't have any existing artifact management facilities, right? So there was no way for the team to spend a lot of time to set those up as well. And that's why we ultimately chose mono repo. However, you always have to anticipate changes, okay? Just like when you're designing your app, you're not designing it for Kubernetes. You're designing the app to the best that it can possibly run. Similarly, for the multi-repo and mono repo, we're optimizing the repository for our current situation, but we're anticipating the future and the change that we will eventually outgrow the mono repo and we will go into a multi-repo structure, okay? So we had to design the mono repo in a way so that it's really, really easy to extract my services when we need to. And we actually successfully have done this already. In our mono repo, one of the 2 services, I believe, had to be extracted out because there was a new team that joined, right? And there are new people, which is a separate team, and they are now taking ownership of these services. And it doesn't make sense for those services to stay in the same mono repo anymore because the lifecycle is changing, the team working on it is changing. So we were actually successfully able to extract a couple of services out from the mono repo and putting it into a multi-repo instead so that this other team can maintain it. So the design part of this is very important and also anticipating for the change. So for example, we are using Gradle for this project, and we make sure that the project structure is very clear cut. Even though it's a mono repo, each service is still self-encapsulating. So we have like all of these services under a single directory. However, they do inherit like a common Gradle build file so that they are always built in exactly the same way. And then we make sure that for the dependencies, we can change out these dependencies that's currently referencing an internal Gradle project. We can actually change this into depending on external Maven artifact, for example, so that we can successfully extract these services out very easily. Okay. So one of the things I learned in this exercise was to always consider risks outside of technical choices. Yes, multi-repo is probably a better match. However, there are a lot of risks associated with just going with a multi-repo because it's a technically superior choice in this case. However, we couldn't do it because of other risks, but then we designed it in a way that we can anticipate change. Okay. For service-to-service communication with this microservices project, we are using gRPC, you gotta have a way to communicate with your services, and usually the choice is gRPC versus REST. And we chose REST is usually what people go with, right? It's a text-based it's text-based usually and goes over HTTP, and you can see and test everything really easily. However, it's not the most efficient use of the bandwidth, for example, because in gRPC, everything is representing binary, and also the payload is usually using something like protobuf, so that we can pack the payload down to the smallest possible representation. Okay. And we chose gRPC, of course, because gRPC is created by Google, and this is a Google project. But that's not, of course, not the only reason, right? Because there are definitely benefits for REST or GraphQL, depends on the use case. But overwhelmingly for internal service communication, gRPC has proven to be really useful, mostly because that we define the schema upfront and ahead with the protobuf. So we can create a proto file with a very simple proto language as opposed to YAML files, right? We can use a very simple proto language to define my payload, my response, and also the service contracts in down here, the name of the service and the RPC methods that you can call, and the request and response. Now, remember, gRPC is really not traditional RPC. It's not like a Corba or RMI or anything like that. It's really still based on request and response paradigm. So they're just using HTTP2 behind the scenes and with the binary protocol with their own ways of negotiating. But aside from that, it's not like it's nowhere like Corba. So it's not the same pan, I guess. It's not the same. Okay, so far it's been very, very nice. We can also use the profile, and we generate all the stubs and the objects for the target languages. So for example, in REST, usually what you might end up doing is write your own POJO, and now you have to match it with the schema. Or if you're lucky, you have a schema already, and then you can maybe generating it. But for gRPC, you definitely have the schema, and you can generate the POJOs and also the service stub directly to Java and many other languages as well. In fact, we also generate the JavaScript bindings too. So from a single definition, we can consume the service from Java and from JavaScript without writing any stubs or writing our own POJOs, which is really nice. For the protofiles, we also have to decide on what the schema. We have to decide on where to store it. Do we store in the same directory or individual directories? Again, we are always anticipating change. We know that even though we're using Mono Repo, we want the services to be self-encapsulating so that they can be split out in the center in the future. And so that we are storing these schemas also along with the services themselves, right? Just remember, every one of these services should have everything that it ever needs to actually start and run. Okay. To share some of these schemas, though, we're using Gradle, and we are packaging the schema, the proto file, into a jar file. Okay, so rather than referring the schemas directly from a file system, we are actually packaging these up as a jar so that it can be versioned accordingly, and it can also be published into a Maven repository in the future, so that the consumers, in this case, my application requires the use of the user service. The consumer can really just can reference this artifact and then take the classifier or the configuration in this case to be proto, and the protobuf plugins will then examine the jar file and find these proto files, and then you can use that to distribute your schema, and then it can automatically generate all the stuff for you. So you're really trying to decouple the application, and this really, really helps. Okay. Now, another thing, though, is that from the web application, we needed to make sure that you can connect from the single page app to the gRPC backend, in which case you do need to do some transcoding because the browsers cannot speak gRPC. So you can use something like gRPC web to transcode the web browser payload through a proxy, the transcoder, and then converting that into the actual gRPC binary protocol, and then code the backend. And there's a project called gRPC Web. There are many other transcoders that you can use. We are using Envoy proxy for this, for example, for the local development. We're just using a simple proxy that can transcode this for us. But in the non-local environment, we're using the service mesh. Okay, so we're using EachDo because with EachDo, it does have gRPC web transcoding built in. So we can just transcode by configuring EachDo to do it. And the configuration is very simple. But we're also using EachDo for many other things like load balancing, traffic routing. We're using mutual TLS. We're using egress whitelisting, as I mentioned before. We're also using it for circuit breaking and retries as well. And that brings to the point of, we're actually not running EachDo locally, right? Because we're using the Envoy proxy locally to run our app, but we're not using EachDo locally, right? And that is partially because EachDo will take a lot more resources, or it used to be. And also, there's a lot of learning and troubleshooting to be done, whereas we really just want to focus on the code for the development. Okay. And so in the higher level is where we add EachDo. And for gRPC transcoding in EachDo, all you have to do is to just name the port. So you just name the port with prefix of gRPC-web. You'll do the transcoding for you automatically behind the scenes. Okay, cool. So then finally, we get to the container, right? So we talk about the environment. We talk about the Mono Repo, multi-repo. We talk about the service-to-service communication. And now finally, we're talking about containers. And notice that we haven't even gotten to Kubernetes yet, right? Because all of these are fundamentals that we have to make sure that we do well before we even consider the runtime environment in this case. So initially, the team may have started with a Docker file, right? So the Docker file, usually you just start a Docker file, put a from, and then you copy the jar, and then you entry point it with java-jar, and you ship it. And that is definitely not production ready. There are so many more things you have to consider when you are creating the container image. I have seen many bad Docker files, and most people do not know how to write a proper Docker file, and that is because it's difficult, it's error prone. So one of my friends, Matt Rabel, who is a developer advocate at Okta, because it's a security company, they deal with authentication. His famous word is, friend don't let friend write authentication. Why? Because it's error prone, it's repetitive, and you should just use a service for that. So what I'm gonna say is that friend don't let friend write Docker files, because Docker files is the same thing. You don't wanna write the same Docker files over and over again. You can just Jibe it. Jibe is actually a really nice plugin that is produced by Google. And we're actually using that ourselves as well for this project. So with Jibe, you do not need a Docker file. You just need to add a plugin here in Maven or Gradle. And you can specify the from image, which I'll get into in a second. So you can specify the base image. Or if you don't specify it, we'll give you a default one. And you specify the name of the image you want to produce. And more importantly, here you can also specify a different username and group so that you are not running as root. And without actually having a Docker file, what we can do then is to do a compile. And if I want to build it into my remote repository, I can just do Jibe build. So I can say compile and Jibe build. And what this will do is to analyze your Maven build file or your Gradle build file. You'll automatically understand who are the dependencies and the classes and the resources, and will automatically split the layers for you to the most efficient ways, right, in the best practices ways, and then produce your container image very quickly, even without Docker installed locally on your machine, which is super nice. If you do have Docker installed locally on your machine, then you can do something like Jibe Docker build. And if you do it this way, it's going to build the container into your local Docker daemon. You can do this all without having a Docker file at all. Now, going back to the configuration here, another very important part is to make sure that you know what JDK version you're using, because not all JDK versions are the same. Some of them do not behave well in the containers. So for example, and this is really important, everyone here should go back and check their JDK versions. If you plan to use containers, you need to know what version you're using, right? So for example, if I were to run something like, here I'm gonna use OpenJDK. Let me zoom in a little bit. Hopefully that's big enough. So I'm gonna use OpenJDK here. So I'm using a version that I know is not container compatible. So it's 8U141. And what I'm gonna do is to restrict the memory of my container to 256 megabytes and the number of CPU to just 1. Okay, and what I'm gonna see is the max heap. that this JDK things that I can actually use. I have not explicitly configured anything for max heap yet. So the JDK is going to go out to my system and discover what the max memory it can actually use, and then maybe take a fraction of that to become the max heap. So in a non-compatible JDK version, this will become, let me see here. That's the number of bytes for the max heap. And I could never convert these bytes into megabytes or gigabytes. So I'm gonna do a little calculation here. I don't know if anyone here still use Perl, but I use Perl religiously when it comes to calculations. Use Perl like a calculator. So I'm going to say, here's the bytes. I'm gonna divide by 124, that's K, and then megabytes, and then maybe gigabyte, okay? And that will give me 1.2 gigabytes, just about, right? So even though my memory for Docker container is limited to 256, Java thinks that you can use 1.2 gigabytes for the heap. And then what's going to happen is that your application might consume the memory a lot faster, very aggressively. And before Java will GC, garbage collect, because it thinks you have 1.2 gigabytes of heap, you're going to cross the 256 megabyte threshold, and then Docker is going to go ahead and kill your container runtime. And that's where you see this arrow all the time, which is OM killed. It's most likely you are running the wrong JDK version. Similarly, if you check out the threads are also incorrect. Even though I only allocated one CPU, in this case, the older version of the JDK does not understand this restriction. So it still thinks you have as many threads you can use as your host machine. In this case, it thinks that you can have eight threads, right? And that's also dangerous because we do use the number of CPU cores as the size of our thread pool, and you could very easily over allocate. I've seen this a lot when either the C group, the container information is not exposed properly, or when the JDK version is outdated. Now, finally, if you do run AU 222, for example, where everything's kind of fixed, we can see that the amount of memory is actually much, much smaller. So if I do the same thing here, let me just get to the megabytes. That's about 107 megabytes, right? And similarly, the thread numbers will be correct as well. Okay. So just make sure that you choose the right JDK version. In addition to using tools like Jibe that allows you to implement or build container in the best practices way. Okay. And finally, I'm gonna move on here. Finally, Kubernetes. For Kubernetes development, developing with Kubernetes, there are two options. You can either have a shared cluster that your organization may have, and each user may get their own namespace within the cluster, and then you can start using that cluster, Kubernetes cluster, with other people. Or in our case, we actually chose to use, focus on the local development and make sure that everything's local and reproducible locally. So the team started off with Docker Compose. It was really easy to get started, but then it actually did differ from the runtime environment a little bit too much, so that we wanted to run Kubernetes locally too. And there are some really, really cool projects out there that you can try. If you're on Linux, your choice is a little bit more. You can run, my favorite project is called K3s. It's really, really tiny and nimble Kubernetes distribution where you can set it up on Linux machine in about 30 seconds, right? And all it takes is, let me see if I can find k3s.io. Yeah, all it takes is running one of their command lines here. If you trust it, you curl it, you run the shell script, and then in 30 seconds, you get a cluster up and running. That is really, really cool. The other way, what we have used in this project is called Kind. Kind stands for Kubernetes in Docker. So if you have a Docker daemon running already in Linux, why spin up a separate VM for it? So you can actually just run Kind, and what this will do is to run all the Kubernetes infrastructure and the components directly in the Docker daemon that you already have. Okay? And this is really neat and really easy to use. In fact, people use Kind to even spin up these ephemeral test environments so that in your testing pipeline, you can actually use Kind to spin up a Kubernetes environment and run all of your real integration tests in Kubernetes, and then you can shut it down or shut down the Docker daemon, and everything kind of goes away. But if I'm using a Mac, which that's what I'm using, then my choices are Docker for desktop or Minikube. Either one are really, really good. Just like friends don't let friends write Docker files. My other friend, Burr Sutter, heard it, and then he once said in DevNexus, said the keynote that we presented together, he said, friends don't let friends write YAML files. Okay, and so if you don't want to write YAML files, that's good. In fact, if you can generate it, that's even better. So the little tip and trick here is that you can actually use kubectl command line to generate the Docker file for you. So if you know the container image you want to run, you can just do kubectl create deployment. And then the trick here is by using --drive run and -o YAML, and that's going to generate the YAML for you into std out. And then you can just output that into a YAML file, and you can keep it. And the important part here is that you do actually want the YAML file. You definitely want it. You just don't want to write it yourself in many cases, unless when you're starting to tune things. But initially, you don't really have to worry about writing it. But you do need a YAML file to be checked in. That is the best practice. That will allow you to be able to reproduce your application in a consistent way. And without the YAML file, we're going to go back to shell scripts and just creating my deployments with a SH file. And between bash script and YAML file, I think I prefer YAML file a little bit more. Okay. Or here's another project which is called Decorate. I learned this most recently, where you can simply add, and this is really, really cool, you can add a Decorate dependency here. It's a annotation processor tool, so it generates based on your code. And then they have different integrations with different frameworks. I'm using Spring Boot, so I'm using the Kubernetes Spring Starter. And if you use the Decorate dependency here, and if you go back to the code and do a Maven clean and package, for example, again, I'm going to skip the test because of the time. I'm going to do clean package. With Decorate, it's actually going to, in this case, automatically introspect your Spring Boot configuration. And then it will generate the YAML file for you. So under classes, here is the generated file, and it's kubernetes.yaml. And if you look into it, it actually has everything that you need. So it has a way for you to expose your application as a service in Kubernetes. It has deployment automatically created for you. In my case, I am even using the Spring Boot actuator. So it knows how I have the Spring Boot actuator. So it also automatically generates the Liveness Probe for me, and also the Readiness Probe for me. Okay, so this is one representation, one example of where you can use tools to help you generate these YAML files. There's definitely going to be more and other ones in the future, I'm sure. But this is a very, very good way to just get started to see what all the possible configurations are. But once you do have these generated, then what you need to do is to make sure that it also lives with your code base. So in this case, I have this very simple base YAML configuration that's being generated for me. And then I'm changing out the container image. And now this is ready to be deployed. Okay. Now, the final thing that I'm going to show a little bit about is how do we actually develop my application if I really, really want to see it? Now I have the Kubernetes cluster running locally, right? I done all my tests. Now I really want to see the app. I want to see and make sure everything works properly. I want to do a walkthrough of the app before I check in the code, just to be double sure, right? You can, of course, just go ahead and deploy this YAML file, right? So for example, you can do kubectl apply this YAML file, and this will go into my Kubernetes cluster. But then once you see something you want to change, what happens then? What happens then is that you have to come back to the code, you make your change. Once you make the change, you go back to here, and then you do a Jibe build, right? And you build your container image. And then you need to undeploy your existing app and or kill it so that it will restart with a new application. We actually have a tool that can simplify all of these things, and that is called Scaffold. So actually, even here in the IDE, another tool here that I'm using, that we're using also is Cloud Code. So it's a plugin for IntelliJ and also VS Code. So if I am using Jibe, I can simply come here and say Kubernetes and add Kubernetes support. If I click on this, what this will do is to automatically generate the Scaffold file for me. And what is Scaffold? Scaffold is very similar to Docker Compose in a way, except that it's really focused on Kubernetes, where you can specify the multiple projects you want to build. You can specify the target container image you want to build to. In this case, I'm using Jibe, so we have a special hook for Jibe. And what this will do is that if I am going to run this application, even from the IDE here, this will be done automatically through Cloud Code. You can run this from the command line, or you can run this from the IDE. If I run this, what this will do is to automatically compile my code, automatically create my container, okay, and then subsequently automatically, whether you upload the container to a registry or if you put this into a Docker daemon, okay, and then it's going to deploy the YAML files here that I have, okay, and it's going to wait for all of the applications is up and running. So I'm just gonna wait for it a little bit, and I can come back here and just do a kubectl get pods and make sure that everything is almost running. And then a little trick here is you can see the logs, or with the plugin here, I can go to Kubernetes Explorer on the right. If I go to Docker for desktop, I can go into my default workload, see the pod, and I can even stream the logs here directly. Okay, so it seems like my app is running now, right? And I should be able to go ahead and access it, right? So Scaffold will do all of these things for me automatically. And even that, if I go back to the run, when my application started, it also did two other things. I'm not sure if I can zoom, but first of all, I get to see the log being streamed to my console. This application is running in my Kubernetes cluster, but it's now streamed to my console. But it also configured the pull forwarding so that I can actually test my application and run it via localhost. Okay, and if I go ahead and do this, if I say curl localhost 8080, this will actually forward the packet, the connection via the proxy, via pull forwarding directly into my Kubernetes environment. And then through the load balancing there, it's going to route the traffic to my backend, which has only one backend right now. Okay. Now, similarly, if I come back to my IDE, if I do discover a change, and I do want to make a small change here, right? And I can just go ahead. I'm going to go ahead and create a new controller here. That's something like you'll say hello back to me, okay? And if I go ahead and save it, Scaffold and Cloud Code will automatically detect this change. And once it detected this change, what this will do is to rebuild my application for me, and then redeploy the application for me as well. Okay, so I'm gonna see if I need to trigger this with the build project. Okay, and then it should trigger the change here, and then we'll do the redeployment subsequently. And that's a very, very easy way to do iterative development if you need to, in order to test changes and see it taking effect. You can even go ahead and try the debugging. So up here we have a debugging icon too. So if you run with Scaffold, we can also, or Cloud Code in this case, we can also automatically launch your app in Kubernetes using the YAML files that you generated, and then we'll automatically turn on the debugger port, and it will automatically forward the debugger port as well. And from there, we can go ahead and debug your application directly within the IDE too. Okay, so that's just some tools that we have created: Scaffold and Cloud Code. Now, the final piece to this is that for operating environments, so for example, what we wanted to do was to keep the Kubernetes YAML file very, very simple for the services, for the developers. But when you move to an operating environment like staging or production, the configuration gets more and more complicated. So the simplest thing that I can show is that maybe for your replicas, for the local environment, you are running just one instance of the app. But for the staging environment, maybe you want to run two instances of the app. Then what do you do? In this case, you either have to copy the file and recreate one, which then you have two copies of the same file, or you do some templating with the templating engine. right? Now you need to remember which variable can you actually modify. So we have another project here called Customize. So with Customize, what you can do is you can keep a catalog of all of your resources. So in this case, my base catalog resources is the demo YAML in my Postgres database. Okay, I want to be able to consistently recreate these two components. For my staging environment, what I'm going to do is I'm going to inherit. So rather than copy, I'm going to inherit my base configuration. I'm going to just update one thing. And what am I going to update? In this case, I'm going to update the number of replicas from 1 to 2 or 4, depending on the environment that you're running on. And then what you can do is to go to this directory, customize and staging, and you can do a customized build. And what this will do is to merge the two configurations together. So it's going to take the base configuration, okay, and then lay on top of that the changes that you have modified, the patch. So the patch that I added is the number of replicas. And let me see if I can find the replicas right here. Replicas is equal to 2, okay? And that is the patch that I applied for the staging environment. And I can use the same paradigm to patch, for example, my configuration. For my Spring configurations, I can patch anything that is specific to that environment so that the developers doesn't really have to worry a lot about what the other environments need. And these patches, again, can be stored in Git repository, and these YAML files will be reproduced with the customized command line over and over again very easily. Okay. Now, the last thing I'm going to do is to talk a little bit about Liveness Probe and Readiness Probe. And this is important in Kubernetes. You definitely want to at least have a Readiness Probe, because the Readiness Probe is the thing that checks whether your application is ready to accept traffic. Okay, so a lot of people use the health check endpoint to do that, but you might want to consider other endpoints. The reason for the Readiness Probe is to figure out whether your application is ready to accept traffic. Because if you're not, then we're going to remove you from the load balancer. Okay. So one thing to consider here is what constitutes ready to serve traffic. If your database is down, can you still serve traffic? In some cases, yes, because you have good circuit breaking so that you can serve a error page that tells the user that the database is down or that you're temporarily unavailable, as opposed to shutting down the entire app, which then nobody can get to the app in the first place. Okay, so be very careful about what you check as part of the Readiness Probe. Similarly, for the Liveness Probe, this is the probe that will kill your app if it fails. Okay, so the thing to consider here is, can my application recover with a restart? A lot of the times we restart our JVMs once a week. I know some people in here still do that, but that is not the root cause of your issue. You don't want to just restart it and mask around the problem. You do actually want to get to the root cause. But can the problem be resolved if you restart? And unfortunately, yes, right? But then there are other problems that cannot be resolved if you restart your app. So for example, if your database is down and your Liveness Probe fails because of the database is down, and Kubernetes will restart your app, and restarting your app doesn't fix your database, right? So now your app will always be restarted until it will go into a back off, and it will not start at all for a long period of time. Now imagine if a consumer of this service who uses your service now also have a Liveness Probe that depends on your service, and now that application is going down too. But can restarting that app fix your problem? Definitely not. So now you're going to have a cascading failure all across your entire microservices ecosystem, and for no good reason, because you're not actually fixing the root issue. Okay, so be very, very careful with these choices that you're going to make. Okay. So I know that with the time, let me just go ahead and go to the last slides here. We went through a lot of the details on the considerations for our microservices architecture, some of the best practices that we learned, some of the tools that we have been using. And just remember, the road to production is even harder, right? Because now you have to consider many other things, pod security policies, the VPCs, NAT, right? There are a lot of things you have to do to harden the the actual environment. One last note is that you do want to try these things out early, right? Even though you don't want your development environment to have any of these things in, because it could weigh you down. But it's really good to have these things early, try it out in a lower environment, so you can fix all the issues. Because every time you tighten the environment, you're going to get more problems. Okay. And just to recap of the things that we learned, right? ClipOps, make sure you use GitOps instead. The dev and prod environment, they're not the same. Focus on the development part and try to run and test everything locally. Know your JDK version. Don't use the one that's outdated. Use the newest one that's actually container ready. And friends don't let friends write things that's repetitive and error prone. Always try to use tools that can automate the best practices. If the tool does not exist, you should consider writing one. And understand the application lifecycle, especially the Liveness Probe and the Readiness Probe. And just remember the tools that we all have been using so far. Okay, so with all that said, thank you so much for being here. And if you have any questions, I'm more than happy to answer. And you can check out some of the links here to learn more about running your Spring Boot or Java applications in Kubernetes, and also some of the best practices I talk about. Okay, so that should be it.
And that was it. That was it. And what a glorious it was. It was terrific. It was terrific. I enjoyed it very much. Thank you, Ray. This was a very fast-paced session. I felt the introduction. I think the introduction set a little bit unexpected expectations for me. Right when you started with dunes and this trip in the desert, and I was very relaxed. I was, I'm in my happy place. And then in 2 slides, we're talking about Scaffold and Kubernetes.
Yeah.
But it was super educational. So I loved it a lot. We don't have a lot of questions, to be honest, surprisingly. Yeah. I thought there would be more questions. Ankit is asking, is this Scaffold thing only works with IntelliJ? Double question.
Right. No, actually, so we have plugins for for VS Code as well, and you can always just run this locally via the command line. So we can come here to the console and just say Scaffold dev, and what this will do is do exactly the same thing as the run button has done in the IDE. So even if I go back to the IDE, to the debugger or running Kubernetes, if I scroll up, it actually gives you the exact command line that's being run, so you can run the same thing anywhere else in addition to the IDE.
Right, I think that answers that. I have a question of my own. If I just interrupt the normal flow. So my background is a lot of Java development, right? Yeah. Not a lot, but like some Java. My main background is a Java developer, right? So now I'm entering this world of DevOps, Kubernetes, and I'm kind of confused by the amount of terms that I need to learn. Like, what's the difference between Helm and Terraform, right?
Right.
What is Scaffold? What is better, Jibe or build packs, right?
Right.
Like sometimes to me it feels like entering the JavaScript ecosystem. So my question is, like, what would be the best resource like that you can think of on the spot like this for this total newbie, right? So I understand the general like networks a little bit. Like I understand that there is a network, right? And then there are clusters, and there are some like an application server or a container, something that needs to be running, right?
Yeah.
But like, what's the best resource to start learning about Kubernetes, not to get overwhelmed with the code names for the projects and everything? I want this simple happy path.
Yeah. So I think that the way I learned about all the things I know about so far is that it's always useful to spend time and understand the foundations. Okay, all the tools I show are things that's a little bit above the foundations because it generates the YAML file, but what did they actually do? What's in the file? that's also very important when it comes to the data. You actually have to understand the entire thing, right? So some of these tools are really easy for people to get started, right? So for example, I would say, maybe just use decorate, right? So you don't have to write your own YAML file. Run a local Kubernetes cluster and just deploy something very simple. However, it's really, really important to also understand all the fundamentals, right? And I do have a workshop that I used to run, and all the material is still there, which is the fundamentals of Kubernetes and how a Java developer can get started quickly. In that workshop, I can share the link. Actually, you know what? I think it's called bit.ly KS Lab. So this one. Okay. And you can actually go there and try things out. And this is a little bit more than just, and look, there are always like some people in here. I don't know who they are. They're all anonymous, but you can go there. This is gonna be more involved than say something like running than just kubectl create a deployment with Nginx, right? Because that's very, very simple. But this one is a little bit more involved, where you do get to see and understand, hopefully, why the YAML files are there, what are these files actually doing, what configuration knobs can you tune, how do you actually do a scale in and rolling updates, rollbacks, and how to properly implement the health checks and graceful shutdown. So this is my collab that I usually bring people to, but it will take about 4 hours, if not more, to go through the whole thing. But you really have to sit down and understand the fundamentals. Once there's the fundamentals, then there's a proliferation of tooling that you can choose, right? So for example, if I were to learn about, okay, so this is how I create a new container. Now, what other tools can I use to create a container, right? Sometimes the tutorials are overly simplified with a simple Docker file that is actually not production ready. Okay, so you gotta be careful with that, right? Not all tutorials are the same. Many of them are very simple, but they are potentially not production ready, in which case you then need to learn about production ready Docker files, right? Right, so just be careful. And that's why some of the tools that you can then automate that implements the best practices is probably the way to go. But after understanding the fundamentals, go to the best practices that the tools implement. That is probably my suggestion. Yeah. Oh, I see some people joining now. So to this collab, we can even run this collab in a virtual session if you want, Oleg.
Oh, like a virtual workshop.
A virtual workshop. Think about that. Yeah.
That would be very interesting. Like in the past, we run those virtual JUG 24 conferences, 24 hours, the whole day. Maybe we can do like a virtual JUG 3.5, like the workshop edition.
Yeah.
Excellent.
Yeah.
No, the link to this lab, thank you very much. It's actually a very good resource. Of course, I didn't see that before, but like you scrolled back and forth, and I think there were a couple of just topics that actually answer my questions. So I like that very much. And I shared this link in the Slack channel, in our live session channel. So if you're watching this on YouTube later, you can then rewind and just type the URL in. Doesn't matter. So that's how the people got in. I have one more question from from Indie Trends in the YouTube chat. And the question is, what is an actuator?
What is an
actuator? I think you mentioned actuator, yes, somewhere. And then, or it could be that this is an irrelevant question, and I think you mentioned actuator.
Let me see here. I'm gonna search my slides. Maybe I said it incorrectly.
Maybe misspoke. Indeed, in the YouTube chat of the session.
I do have. I mean, there is something called actuating. There are different concepts of actuating. So, for example, when you turn a YAML file, or in this case, a Terraform file, into the actual running system, sometimes we call this actuating. So we're actuating from an action or the data or the configuration. We're actuating it to become a reality, to become the real running thing. So for example, in Kubernetes, if I want to actuate my application, given a YAML file here, given a YAML file, right? If I do kubectl apply -f, like that, and when Kubernetes goes out and actually creating this application, spinning this up in my VM, and spinning up to the number of replicas that I need, that will be pretty much actuating the application. Similarly, if I do tf apply, a set of Terraform file, sometimes we call this actuating the Terraform files as well. So.
Right. Normal people call this executing, but you cannot execute a YAML file, so you actuate it.
Oh, okay. So I think somebody clarified this on the chat on Slack. The actuator I did say is the Spring Boot actuator. Sorry about that. So there is actually a Spring Boot actuator that you can a plugin or a dependency you can add to your Spring Boot application. Yeah, I actually did not talk a lot about this one, but add this to your app, and this will automatically add the health check endpoints for your application. Yeah, so for example, if I do have this actuator running in my app, let me see here, if I do Maven Spring Boot run, and this will automatically add additional endpoints under /actuator URL that I can hit. So for example, I think my database is down right now, but the /actuator health, this will be provided by the actuator dependency, and this will give you the health check endpoint, and the /actuator info, that will be the you can use that for the liveness check, for example. Yeah. Yep. So we can paste the link to the Spring Boot actuator itself later. Yeah.
Right. So another question from thin air, out of thin air. So Java
from
14.
You mean?
Java 14. No, it's not for me. I'm not signing off on that. Java 14 was released, I think yesterday, right?
Okay.
So when do you think it will be supported on Kubernetes, Google Cloud Platform? Anywhere else you can answer?
Well, Java 14, if it's a if there's a container, I'm sure there is. I think I just saw the adopt OpenJDK container has been updated too. If there's a container, then you can just deploy this into any containerized environment. So for example, if I am really brave, I'm not today, but suppose I change this out, my base image out to adopt OpenJDK. Hopefully they have the 14. I'm not sure if they do. I think I just saw a tweet recently, but we need to double check, right? So if you rebuild your container image with the base image, whether it's OpenJDK or adopt, then now you're gonna be running this with OpenJDK 14, and your app will just start. And because containers doesn't really care what you bring to the container, so you can run whatever that you want. In fact, if you want to run it in Kubernetes, you can build the container image right now. And then just run in Kubernetes however you want. On Google Cloud, you can run whatever you want in Kubernetes or in Cloud Run. So we have a container as a service kind of thing, a serverless environment, where that if you have a container, you can just run it, we'll spin it up for you, and we'll automatically scale it based on the HTTP traffic. So that would be a pretty interesting thing to try.
Right.
Yeah,
I've heard of that.
We can even run Graalvm VM images. So if you have a native image, I know, like you love Graalvm VM. If you have a natively built container application containerized to the Linux binary, we can run all of that in Kubernetes or in the Cloud Run environment. Yeah,
that's amazing. And I do love Graalvm. Right. This is the last call for the questions in the chats. I don't think we see any both on YouTube or in the Slack. So thank you very much, Ray. It was a very interesting session. Not just this feedback is not just from me. It's both in the Slack and on YouTube. It was great to host you here again.
Thank you for having me.
Absolutely. Everyone else who is watching us on YouTube, stay safe, wash your hands, take care of the close ones, and learn more Java and Kubernetes. Thank you very much. Thank you, Ray. Thank you, Laurie. Bye-bye.
Bye.